Hello everybody, welcome to this brief review of what you need to know about the unit circle for the AP Calculus test. And our learning goal is that you'll be able to use a pattern and mathematical reasoning to determine the trig values you'll need on the unit circle on the fly. Okay, so let's get going. Okay, so what is it that you need to know about the unit circle for the AP Calculus test? Well, they expect you to know by memory the values of all 6 trig functions at all multiples of pi over 6, pi over 4, pi over 3, and pi over 2 radians. That's a lot to memorize. And so it would be pointless to try to just memorize every single value at all those multiples. Your brain couldn't contain it. I mean, you could try, but to help you generate these values, instead of memorizing each individual value, then you can just, if you remember the pattern in these trig values within the first quadrant, and you can draw this diagram just on the fly whenever you need it, you can just generate the trig value you need and move on. Okay? I'm going to show you how to do that and show you what the pattern is. For each one of those rays there in the first quadrant, you do need to remember these what radian value they represent: 0, pi over 6, pi over 4, pi over 3, and pi over 2. Okay? So the unit circle intersects each of those rays at specific points, and it's those coordinates of those points that help us find the trig values. Okay? The 0 radian line is the x-axis, and the pi over 2 radian line is the y-axis. Okay? Because the unit circle has a radius of 1 in every direction, then the coordinates on the axes are pretty easy to remember. Okay, the coordinate on the x-axis is 1, 0, that's 1 away from the origin, and the coordinate on the y-axis is 0, 1. Now what about the other coordinates here? Okay? This is where if you know this pattern, then you can generate these coordinates on the fly pretty easily. Okay? So it turns out that all of those values are something over 2. That's convenient. And so starting from 0, we're going to fill in the values. So 0 on the x coordinates, starting from the y-axis, is at 0, 1. We're going to count up by ones and put them under square roots. Here's what I mean. So the next value is the square root of 1 over 2. The next one is square root of 2 over 2. Then square root of 3 over 2. And then 1 finishes the pattern because 1 is simply square root of 4 over 2, because it's 2 over 2. Okay? Then using the y-coordinates, we'll count backwards from 0 there. Okay, going up on the coordinates. So we'll have that's square root of 1 over 2, then square root of 2 over 2, square root of 3 over 2, and again 1 finishing up with square root of 4 over 2. Okay, here I have all the coordinates of those points that I need in the first quadrant. Okay, so how do they get me the trig values? Oh yeah, and I should point out first before we go on that obviously square root of 1 is just 1, so I could really write that value as square root of 3 over 2 comma 1/2. But if it helps you, this pattern helps you remember, so heck, they're not going to count it wrong if you put square root of 1 over 2, so go with it. Alright, to determine the trig values, okay, the value of the sine is the y-coordinate of that point, and the value of the cosine is the x-coordinate. So each one of those points on the unit circle, it has a value of cosine, comma, sine. Let's look at some examples to help you out with this. Okay, let's practice using the diagram to determine the value of some trig functions. Okay? Over time, I hope that you get really good at building this diagram from scratch really quick following the pattern. And then once you do, you can just get the trig value you need and move on. So let's look at the first one, sine of pi over 6. So to find that value, I need to look at the pi over 6 ray on the unit circle, and the sine is the y-coordinate of the point. So that would be right here. So the sine of pi over 6 is 1/2. Now the square root of 1 is just 1. Okay, pretty straightforward. How about cosine of 0? I need to look at the 0 radian ray on the diagram, and the x-coordinate is the cosine, so that would be 1, so cosine of 0 is 1. Okay. Now what about these other trig functions here, tangent and cotangent and all those? Well, for those other trig functions, you're going to need to remember their relationship to sine and cosine. This is something you learned back in pre-cal again. Okay. How much do you remember? So pause the video real quick, see if you can fill in those expressions with how tangent and cotangent and so on are related to sine and cosine, and then come back. Okay, so let's see if you got it. The tangent is equal to the sine of the angle over the cosine of the angle. The cotangent is the reciprocal of that, and cosine over the sine. Then secant is 1 over the cosine, the reciprocal, and cosecant is 1 over the sine value. Let's apply those to this diagram. So let's take tangent of pi over 3. It's going to be some fraction, a sine value divided by a cosine value. So I need to look at the pi over 3 ray. The sine value is going to be the numerator there. So that's the y coordinate of the point. Then the denominator will be the cosine, which is the x coordinate. Notice both of these values are over 2. That can cancel, and I end up with square root of 3 over 1, or just square root of 3. There, I found the tangent of pi over 3. Okay, what about cotangent of pi over 4? Think you can do it? Pause the video real quick and then come back and see how you did. Okay, so here we go. Cotangent of pi over 4 is going to be square root of 2 over 2 over square root of 2 over 2. Where did that come from? Okay, the numerator is the x coordinate because that's the cosine value. The denominator is the y coordinate, or the sine value. And, oh look, the numerator and denominator are identical. Anything divided by itself is 1. There we go. Alright, how about the cosecant of pi over 3? Well, that would be 1 over sine of pi over 3. That sine of pi over 3 is the y coordinate. So 1 over the square root of 3 over 2. I'll help you out with this one. If you do 1 over a fraction, dividing by a fraction is the same as multiplying by its reciprocal. So the reciprocal of square root of 3 over 2 is 2 over square root of 3. Okay, we do have a square root in the denominator here, but good news is that on the AP test you can leave a square root in the denominator. There's no math police coming after you. You don't have to rationalize the denominator, any of that stuff, and you can just leave it. So we're going to leave it. Okay, so last one here. See if you can do the secant of pi over 2. And pause the video and come back. Okay. Secant is 1 over cosine. Okay, so I need to find the cosine of pi over 2. Cosine of pi over 2 is the x coordinate, highlighted in pink way over there on the left. So I have 1 over 0. Oh, so that means that the secant of pi over 2 is undefined. Alright, so hopefully that's a good refresher. These are the kind of angles that you'll need to find the trig function values for mostly. Usually the ones you find most are in the first quadrant, but you might need to do some trig values for the other quadrants as well. So let's give y'all a quick review on that. If the radian measure that you're interested in is in a different quadrant other than the first quadrant, you'll have to reflect your drawing of the first quadrant over either the x-axis, y-axis, or both to get the radian measure that you want. Okay, so again, hopefully you are getting better at drawing this kind of diagram on the fly as the more you do it. Okay, and now we're looking at the entire unit circle, not just the first quadrant. All right, let's find the values of these trig functions here. Okay, in number 7, I'm looking at cosine of pi. First, I need to know where pi is. These first few, hopefully you remember, but just in case you don't, okay, to locate pi, no, we've already, to rotate 90 degrees is pi over 2. That's how we got to the y-axis. That's half of pi. If I rotate another half of pi, I get to pi. 1 whole pi. Pi. Oh, okay, sorry, I got distracted. So, we got pi over there. We need to figure out the coordinates of that point. Okay, being on the other side, it's just simply negative 1, 0, since we're negative on the x-axis. If I'm looking for the cosine of pi, that would be the x value, so we're looking at negative 1. There, not too bad. Okay. So what about this next one? Cotangent of 3 pi over 2. Try to figure it out real quick. Pause the video and come back. Alright, well, when I looked for this radian value, I like to think of it as 3/2 pi rather than 3 pi over 2. It more intuitively makes sense. So I'm looking for 3/2 of pi. I've already gotten to 1 full pi. If I want to get to 3/2 of pi, I just need to add 1 more half of pi. So that's the negative section of the y-axis. Coordinates of the point are 0, -1. Okay. And since I'm doing cotangent, I need the cosine over the sine value. Cosine value is the x value, so 0. Sine value is y, which is -1. So I've got 0 over -1, which is 0. How'd you do? Okay, so the ones on the axes are usually not too bad. The other ones kind of get a little bit more complicated, but I'll walk you through one. So now let's look at sine of 5 pi over 6. I like to think of it as 5/6 pi, and that's 1/6 of pi less than a full pi. So if I go backwards by pi over 6, I'll get to 5 pi over 6. How do I get the coordinates of that point? Well, that point is just a reflection of this point over here. Because it's a reflection, it's the same coordinates, it's just now, since I moved over to the negative side of the on the x-axis, this is -3 square root of 3 over 2 instead of positive. To get the sine value, I'm looking at the y-coordinate. So it turns out that the negative didn't matter in this case at all. And my answer is just 1/2, remembering that square root of 1 is just 1. Alright, now you try the last one. Pause it and come back. Okay, so we got 7 pi over 4, 7/4 pi. So that is 1/4 of a pi less than 2 pi. Okay, where's 2 pi? Well, pi, we rotated 180 degrees. 2 pi is another pi after that. We're back at 0. 0 and 2 pi are the same ray. Okay, then we've got 1/4 pi less than that, so I'm going back by pi over 4, and I've got 7 pi over 4. The coordinates of this point are the coordinates of the pi over 4 point reflected over the x-axis, meaning the y-coordinate is going to become negative. For the tangent, I need to do the sine value over the cosine value. Sine of 7 pi over 4 is -2 square root of 2 over 2, and the cosine value is positive square root of 2 over 2. If I divide those, we get -1. Same value over same value, except the numerator is negative. Alright, so that was a brief overview. If you have trouble with these kinds of remembering some of this unit circle stuff, feel free to ask me. You can also go ask your pre-calculus teacher, or go find some other videos on YouTube that explain the unit circle. Maybe someone else's method will make more sense than mine. Alright, well, have a good one. I will see y'all later.